friend, me H.N. Upadhyaya would like to welcome you in Math Art Studio. Today we are doing enlargement transformation using a kind of straight line drawing technique, straight line patterns. I hope you will enjoy it. Keep watching. Take a rectangular sheet of paper, and in this paper draw two straight lines intersecting each other at a right angle. Divide the line segment in equal interval of 1 centimeter each. So let's do 1 centimeter each. So this is 1, 2, 3, 4, 5, 6, etc. division over there, and here too this much division, and in this direction do the same thing. 1, 2, 3, 4, 5, 6 centimeter. 1, 2, 3, 4, 5, 6 centimeter. Okay. Before I do this thing, I'd like to discuss about the property of a square. And for this one, we can construct a square using two of its diagonal, because the diagonal of a square bisect each other at 90 degree. So assume that these two are the diagonals of the square, they are bisecting at 90 degree over there. Then we can construct the square by joining its endpoint like this. This is another method of constructing a square, and we will be adopting this method to construct a square in this sheet of paper. That's why now take the diagonal to be equal to 2 units, 1, 2, 2 units, 1, 2, 2 units, and they are intersecting at this point. You can name this point as O. And now join the end point of the diagonals this way. This is a square. Here area is equal to, when the diagonals are given, area of a square is defined as half diagonal square. So that is half into diagonal is 2 square, and that gives us 1 by 2 into 4 is equal to 2 square units. So remember that this square has an area of 2 square units. Okay, let this square be A, B, C, D. Okay, now let's construct another square taking the diagonal just double of this one. So from here to here is 2 units, 1, 2, 3, 4. It was 2 units longer, and now we are taking the diagonals to be equal to 4 units longer. Just double of that one. That's why if we draw this way, we get another square. We can name it as A dash, B dash, C dash, and D dash. We have 2 squares over here. And now, we'll draw the series of square over here later on, but using these 2 square, we will just generalize the very important property of enlargement. Here we say that square A, B, C, D is enlarged to the square A dash, B dash, C dash, D dash at the center O. The center of enlargement is O, and the scale factor of enlargement, the enlargement ratio, is 2, because we have doubled the diagonal. When we double the diagonal, automatically the side will also be doubled. That's why we are doubling the side of the given square and getting another one by the method of constructing a square using the diagonal property. And actually we are just drawing the enlarged image of A, B, C, D. Now with these 2 figures, before we go to the beautiful pattern, we can generalize very important rule. And now again let's go for area equals to half diagonal square, and in this one too, half diagonal is now 4 units, 4 square gives us 1 over 2 into 16, and this is 8 square units, and this is nothing but can be expressed as 4 times 2 square units. What does it mean? So the area of this enlarged square is 4 times greater than the square of the than the area of the original square. Okay, the object square. The area of the image square is 4 times bigger than the area of the object square. Here this 4 can be written as 2 square into 2 square units. And this 2 square is nothing but it is the square of the scale factor k square into 2 square units. Now let's generalize the rule as k square into area of the object. The area of the image in enlargement is equal to the k square times the area of the object figure in enlargement. So this is a very important property, and we'll check whether it works for another scale factor. Let's say now we are taking 3 times bigger, the diagonals 3 times bigger than this. The diagonal was 2, now it has 4. We are going to take 6 units longer, 1, 2, 3, 4, 5, 6 units longer, and draw another square. Let this be drawn by another color to make a kind of distinction between different kind of images. Okay, so here what is this? Okay, so now let's do it here. Area of this red square. So let me call it A double dash, B double dash, C double dash, and D double dash, like that. So here area of A double dash, B double dash, C double dash, D double dash, something like that, is equal to, again, half diagonal square. Half diagonal is 6 whole square, 1 by 2 into that 6 square is 36, and it gives us, how much is this? This is 18 square units. So 18 square unit is 3 square into 2 square units, and this 3 square is the scale factor square into 2 square units is the area of the given shape, the object figure. Here too, the area of the image figure is the square times the scale factor and the area of the object figure. So this important property we have derived from here, and with this type of technique, drawing several square over here and coloring them with different color gives us a pattern like this. And students love the pattern, and for me the study of mathematics is nothing but it is the generalization of different kind of patterns. These patterns are expressed in terms of mathematical language and formula. Then that becomes mathematics to us. For that reason only I colored this one. Now with this finding, let's make a table of values. We have the object here, and we have the scale factor here, and we have the area here. So with this one, what we can do? The object, let me say the first square is 1, and scale factor is also 1 because we are not enlarging it, we are taking the square itself. That's identity transformation, and area is 2 by our calculation. Okay, And let's go for square 2. For the square 2, we had the scale factor 2 and the area was 8. And let's go for third square, and scale factor was also 3 and the area was, what was the area? The area was 18 square units. If we go for the fourth square, and the scale factor is 4, area is 32 square units. That way, And what is our conclusion with this one? This is 1 square into 2, and that one is 2 square into 2, and that one is 3 square into 2, and that one is 4 square into 2, that way. So these 1 square, 2 square, 3 square, 4 square are the scale factor square into this 2. Everywhere you can see 2. 2 is the area of the given object figure. Therefore, in language, what we write here as a conclusion is that in enlargement, if the sides are multiplied, by k, the area of the image figure is multiplied by the square of the scale factor. That is what we say k square. So this important generalization is very much applicable in most cases while working with enlargement and solving the problems. Well, thank you dear friends being with me. I hope you have enjoyed something on enlargement using the patterns of square, and we have generalized the very important rule. And keep watching my YouTube channel Math Art Studio, and you will be getting new videos and new concepts and new methods in teaching mathematics. Keep watching and do not forget to subscribe it. While you subscribe it, and do not forget to press the bell icon as well. Thank you.